Okay, welcome back, Shabab, to the class. I have said that there will be no attendance today, and I think this is in the first class, because I will dedicate this lecture for solving the midterm, which you know how much was the average. I'm not going to talk about this right now, but I would like to inform you that by solving this midterm now with you here, I hope that of course, it would have been much better to solve the midterm while you have the solution on hand, you know, your marked exam sheets. But as far as, you probably know that having the file in my device here, grading them, and then taking them one by one, giving them to each student is a hell of a job. So I promise to finish this soon. Definitely during the weekend, if maybe today, I don't know. But I'm not expecting it to be easy, unfortunately. Now, for that, I would like you to make note today. If you, probably most of you will need to take note, because my expectation is that I will have too many visitors during the office hours. Now, as of today, I would like to inform you that I had an escapable meeting at 1:30, which overlaps with my office hours. So I will be available from 1 to 1:30. After that, I will have to, finish the office hour. So my expectation, maybe nobody wants to talk to me now since you don't have the sheet, but if you need to talk to me, you are most welcome between 1 and 1:30. And of course, when you come, ya shabab, get in. I mean, you're waiting. Just remember that I have somebody else maybe talking to me privately. So you need to keep waiting until I admit you, okay? Or if you get in, sometimes I will ask you to get out until the private matter ends. So without further delay, I will try now to solve the midterm. We need to finish. I mean, I barely finished it with the class. So with the other class. So the first question, the designer need to change bearing A and B in the one shaft, and then the other bearing will stay the same. But then we were asked about what type of bearing used in the original design. So if we just construct a table over here, we have A, B, C, and D. And actually, I'm just gonna remove this line because B and C are the same. So what do we have here? We have an angular contact bearing. We have a cylindrical roller bearing. And here we have a deep groove bearing. All right. Now, this is A. Then B. What is the type? What is the name of this arrangement of the how at side A? What is how is the arrangement called? It is actually a duplex face to face, which is DF bearing. That's the type of the arrangement. Now, then we move on to the assessment for whether or not the tapered bearing. Give me 1 second, Ishab. I need to take this phone call. Right, sorry about this. So we went to C then and make that table, which says what are we looking for here? The size, and then the available space, and then how is the evaluation, whether it is satisfactory or not. There are four important dimensions that need to be. So here we're just going to say the dimensions, which are First, in addition to the bore size, we have the width. The width requires 22, okay? And is it in, of course, it's in millimeter. What we have a minimum of a 25. So it is satisfactory. Then the other one is the shaft shoulder. The shaft shoulder is a size 34. We only have 30, so this is not satisfactory. Okay? The housing shoulder. The housing shoulder require 49. We have 45, and the shoulder means that if it is a smaller, it means there is enough space for it to sit. So this is satisfactory. And then we have an outside diameter, okay, which is 52, and then we have 52, and this is also satisfactory. Okay, now the next one, which was a little bit challenging to most of you and a little bit surprising to me, which is, you know, finding reactions and forces. Now, this is the dimension X. Of course, we're talking about the worm. This is X, this is Y. And, all right, this plane is X, this is Z. Of course, ya shabab, although these axes were given to you, but still many students, you know, got confused, and they start solving, you know, they start thinking that there is a force in the X direction while there is a force in the Z direction, and so on. So this is R, B, Y. This one is R, A, Y. Of course, we have an induced load, FIA, because these are tapered now bearings, and we'll have here FIB. What also do we have? We have an axial load acting on the worm. We have a radial load acting on the worm, and because of the shift of the force at the gear location where they both meet, we have a W worm axial multiplied by D worm over 2 as a moment. Okay, now for the other plane, what do we have? We have RBZ, and here we have RAZ. This is A, this is B, and then right there we have the tangential load of the worm. Now, the idea is this. One of the most serious mistake that student did, which by the way wasn't serious in terms of, you know, grade distraction, but in terms of understanding, are those distances. This distance is actually A, the dimension A. If you go to the specification of the bearing, you will find that A is equal to 7.6 millimeter. So this is A plus 36 divided by 2 plus 41. Okay, while this one is A plus 33 plus 36 divided by 2. Now, I want to mention something here very important. If you miss these numbers, you will get, you know, if you forget A, it will change the values for the reactions, but not a lot. It's not like 50%. So if you forgot A, I will take, I really forgot whether 2 marks or even, let's say 4, although I think it's only 2. Everything should go close to the accurate value. But the devastating part is that even those who missed A still did not even know how to calculate the reactions. They got totally different values, And this was the part which was surprising to me. So if you do this, I'm not going to write down the equilibrium equation. I will just tell you how we did them. But so basically, you take the moment about z, which is equals to 0, and then you find RBY, which is equal to 27.9 Newton. Then you find RAY, which is equal to 330.6 Newton. Then you sum up the moment about y and say this is equals to 0. What do you get? You get RBZ, which is equals to 34.2 Newton. RAZ, which is equal to 38.8 Newton. Now, if you now want to calculate the induced thrust, then you need to find FRA, which is the square root of the two component square, and then you need to find RB, which is the square root of the two component square. Okay. Now, when you find this, you can go and say FIA, which is equal to 0.47 multiplied by F radial A, the equivalent, divided by the resultant, and this is going to get you 94.2 Newton. You do the same for B, and what do you get? You get 12.5 Newton. That's what you get. Remember these values. Okay? Now, let's go to the other gear, all right, which is the output, the output shaft. So for the output shaft, we have D and C, and then we have RCY, we have RDY. Of course, the axes are Y in this direction and Z in this direction. Now, this is the mid-span. This is actually pretty easy in terms of dimension. It is right in the middle, 55 and 55. What do we have? We have a moment due to the shift of the axial force, and this is W gear axial multiplied by the diameter of the gear by 2. That's the amount of the moment. And then here we have W gear A, and right down over here we have the radial WAR, and within the page we have the tangential. The tangential component is going to show up on the other plane. So if we have this now, this is the X Z plane, then this is the WTA, this one is RCX, and this one is RDX. And there it is, it's right in the middle. So knowing, ya shabab, that the transmitted load on the gear is equal to minus the axial load in the worm, the radial load on the gear is equals to minus the radial load on the worm, and then the axial load on the gear is equal to minus the tangential load on the worm. And then by summing up the moment about X, which is equals to 0, you will get RDY, which is equal to minus 219.1 Newton. You will get RCY, which is equal to minus 139.5 Newton. You sum up the moment about Y, you say this is equals to 0, and then what do you get? You get RDX, which is equal to 565 Newton, RCX, which is equal to 565 Newton. Now, what is important is if we construct the table, let me just bring the table here and try to draw it for you. So we have the bearing, and then we have the induced thrust, we have the radial load, and we have the thrust load. Okay, so we have bearing A, B, C, and D. Okay, so let me put those values for you. For A, we have an induced of thrust of 49.2. Of course, everything is in Newton.
Doctor, in this thrust section, they said resultant. Did they mean the resultant, the equivalent?
You mean? No. This one is just how much. Do you have an induced and an applied thrust? Kind of, they added together or not? That's it.
Okay.
Okay. All right. So this is the radial 300. Oh, sorry. Let me just make it look nice. 332.9, and this is 1042.5. Then this is 12.5. This is 44.1. There is no thrust over here. And then we have these two guys, no induced, okay? And what do we have here? We have 582, 606, and then 73. The 73, of course, for D, because D is subjected to a thrust load, is taking the thrust, okay? While C is not. Now, we go to the next one, which is the reliability, okay? Now, for the reliability, what you need to understand is that we have two. We have, and let me make it, no, presenter, yeah, okay. Maybe this is easier, is it? Okay, all right. So we have, for the input shaft, we have for the output. So for the input, we have N equals to 1800 RPM. We have L, which is equal to 30 kilo hours. This is based on the recommendation of 8 hours a day. And then you calculate L, which is equal to 30,000 multiplied by 60 multiplied by 1,800. And then what do you get? You get to 3.24 multiplied by 10 to the power 9. So what is XD? XD is equal to 3.24 multiplied by 10 to the power 9 divided by 90 multiplied by 10 to the power 6, which is equals to 36. For the output, we have N equals to 30 RPM and L equals to 30 kilo hours. So L is equal to 30 multiplied by 10 to the power 3 multiplied by 60 multiplied by 30 again, which is the RPM. What do you get? 54 multiplied by 10 to the power 6. So what is XD? XD is 54 multiplied by 10 to the power 6 divided by 10 to the power 6. And this is going to get you 54. That 36 and 54 turned out to be very difficult somehow. I haven't seen it a lot. I haven't. Now, let's move on. Where is that one? Yeah, okay. So we got these values. Now the question is, what is the equivalent load now? For FA, as it is going to take the thrust, it is 0.4 multiplied by the radial load, which we tabulated before, 1.66 multiplied by the resultant thrust, which is the thrust coming from what, ya shabab? From the, I will write it down here. This 1,142.5 is coming from FIB, the thrust going from B to A, plus the thrust load, which was given to you, right? So this is going to give you 2,029.7 Newton. Okay, now FE for B, B is not going to take any thrust, so whatever there is an equivalent is coming from the radial load, so it is 44 0.1 Newton. Now, what is FEC? FEC, as we told you, that FEC is only going to take a radial load. So what is going to be applied there is only the resultant radial load. Yeah, where from the Z and X, you square them under the square root. That's the resultant load. So this is the equivalent. But for FED, since D is going to take a thrust load, yeah, then what do we need to do right here? We go, okay, then we go and calculate FA, which was given to us. Actually, we calculated, which is the axial load acting on D, divided by C0. So this is how much? 73. What time is it? Yeah, it is 73 divided by 6.2 multiplied by 10 to the power 3, which is equal to 0.012. Now we got this value. So what do? Go to the table, and we realize that in the table, we will find FA over C0, FA over C0 is less than 0.14, then we should use FA over C0, which is equals to 0.14. And if we use that, then E is going to be how much from the table? 0.19. Now, if you recall that curve, which has a dot like this, and then all of a sudden we jump up, we told you that this is E. If you are in this region, okay, if you are in this region, it means that little thrust is not going to do harm. It's okay. Just deal with the radial load. If you are in this side, no, you need to take the effect of the radial and the thrust together. So how do we know? Well, let's go. We know how much is the axial load. So the axial load is 73 divided by the radial load acting on D. Where is it? In the table. Look at it. 606. So if I do this 606, what do I get? I get 0.12, right? So if I get 0.12, then this is less than 0.19, which means I am right here, not beyond it, which means I should not worry about the thrust load. Then the end conclusion is that FED is actually 606 Newton. That's what you should do. Okay. Now, what is next? Once we know all the radial, the desired load, once we know the XD, then we know that for the tapered bearings, we have R, which is equal to 1 minus XD, which we calculated, divided by 4.48, multiplied by C10, divided by AFFD, 10 to the 3, and then this one is 3/2. And of course, we know C10, we know AF, we know FD, and we know XD. Now, what about the angular, the roller bearing? Not the roller, the ball bearing. Then R is equal to 1 minus XD multiplied by AF FD divided by C10 to the power A divided by theta minus x0. Here minus is 0, and that's it. So if you do this, you will find that RA is equal to 0.9927. RB is nearly 1, is 0.999 something. RC is going to be 1, and RD is going to be 1 as well. If you multiply them all, you will get R total, which is 0.992, which is greater than 0.97. So we are all set. Now, let me move on quickly to the calculation for the second problem also. So for the second problem, I told you this in the lecture. I told you that the most challenging part in the second problem is probably one number, which is RM, and I'm going to explain it to you here. So basically, we quickly, just to save time, open up. So we were asked in the beginning to find the forces acting on the pinion, then on the gear, and then we want to determine the reactions. So we start with A, finding the forces on the pinion. So we know that the RPM for the pinion divided by the RPM for the gear is equal to the diameter of the gear divided by the diameter of the pinion, which means that in P is equal to 500 multiplied by 200 divided by 100, which is going to give you 1000 RPM. Now, tan small gamma, okay, which is for the pinions, dP over dG, which is 100 divided by 200. So if you take the tan inverse, you will get gamma as 26.57 degrees. Okay, now this is the challenge, and I explained this before to you. I told you that if you look at the pinion and the gear, they are engaged or mating in there, then what will happen is this. We told you that we assume that the whole forces action is happening right in the middle. How do you calculate this? It's a question, right? So how do we calculate it? Well, we go and use triangles, right? The triangles. And if I draw a triangle right here for you, listen, this may not look, straightforward. But I'm telling you, a student did it, not a lot, but it's not impossible. Whoever put his mind on it was able to do it. So in here, that's the triangle. This is the diameter of the gear over 2. And then we have here the face width B. And then we have here the diameter of the pinion 2. And right in the middle over here, I'm going to write RM. That RM is the mean radius. Okay? So what is that mean radius? RM is equal to D for the pinion over 2 minus P sine gamma over 2. It can be shown that this is it. Okay? I have seen some student found it with some, even similar relation, but it doesn't matter. What is this gonna give you? It is gonna give you 45.53 millimeter. Now, why is this very important? Because when you find this, basically, the pitch line velocity 2 pi is going to be multiplied by 45.53 divided by 1,000, and then just to convert it into meter, multiplied by the RPM divided by 60, which is going to give you 4.77 meter per second. Now, when you know the velocity, all what you need to do is to say WT, the transmitted load, is equal to 5,000 divided by 4.77. This is going to give you 1,049 Newton. Okay? When we know the transmitted load, we can calculate WR, which is WT tan phi cosine gamma, which is going to give you 341.48 Newton. Then we have WA, which is equal to WT multiplied by tan phi sine gamma, and this is going to be 170 0.77 Newton. What is happening on the other gear? Gamma capital equals to 90 minus gamma, which is 63.43 degrees. Again, you can show that RM, this is just to show you the calculation, but you can actually, by knowing what's happening on the pinion, you can just reverse the angle and swap the forces to know what's happening on the gear. But just to show you for learning, the diameter of the gear over 2 minus B sine capital gamma divided by 2 is going to give you how much? Is going to give you 91.06 millimeter. Now that's the problem. Some student knew that, for example, the radial load on the gear is the same as the axial load on the pinion. They did it right. But the problem is they did not calculate RM for the gear. And I will show you what are the consequences of this. So by knowing this, okay, what should you do right now? If you calculate WT, you'll get it the same. It will not change. It's the transmitted load. But you will have WR on the gear, which is, so I will put a gear here, which is going to be 170.77 Newton. And you will have WA on the gear, which is equals to 341.48 Newton. Now, this is the most significant diagram that I'm gonna draw over here. The free body diagram, okay? Now, what do we have? What do we have here? Well, we have A right there. We have B right there. And what we have, just based on the solution I have, RAY is here. RAZ is here. It doesn't matter if you put it on the other direction. By the way, a very important piece of information is this. Let me draw it with the same alignment. This is X, this is Z, and this is Y. So what happened? Point O is here. This distance is actually 50. But this from here to there, this one is 45.53, which means that the remainder of the entire length is 54.47. Now, what do we have here? We have RBZ, we have RBY, and I should, oh, sorry. Have here RBX. What is in there? In there, here, we have the axial, of course. We have the radial going in the radius direction of the WR, and then the tangential has to be perpendicular to the plane of both, whether up or down, which is WT. What is this distance, ya shabab? This one is 91.06 millimeter. Now, these dimensions cause problems. That's why RM, if you made a mistake with RM, you did not calculate it. For each RM, you will lose 2 marks. But I promise that you should not lose more. If everything is okay within the calculation. If you feel maybe I missed it, you come and talk to me. So what will happen now? We will go for the XY plane. And then we will sum up the moment about Z at B equals to 0. And what are we going to get? We're going to get RAY, which is equals to 380.84 Newton. We will get from the summation of forces along Y, RB RBY, which is equal to 667.9 Newton. And then from the XZ plane, we will sum up the moment about Y at B, say that this is equals to 0, and we'll get RAZ equal to 145.25 Newton. We sum up the forces about Z equals to 0, and then we'll get RBZ equals to 315.99 Newton. And then if we sum up the forces, of course, about X, we have only one force, which is the reaction BX, which is equals to WA, which is 341.4 Newton. That's it. Now, we go to the next part, which is the interference. For the interference, you have to calculate M, which is NB divided by NA. This is 25 divided by 18, which is 1.389. Then you calculate PT, which is equals to by MT. This is equals to by 3, which is 9.42 millimeter. So psi is equal to cosine inverse of Pn over Pt, which is going to give you 30 degrees. How about phi t? Phi t is equal to the tan inverse of tan phi n divided by cosine phi. And this should give you 22.8 degrees. If you have all of this, you would go and find NP, which is equal to 2K cosine phi divided by 1 plus 2m multiplied by sine square phi t. And then this is multiplied by m plus the square root of m squared plus 1 plus 2m, okay, multiplied by sine square phi t, and that's it. If you do this, you just substitute the number. Make sure you bunch the numbers right, because when you do it by the calculator, sometimes you make mistakes. You get NP, which is equal to 9 teeth. So since you have, for the pinion, 18 teeth, then there is no interference. Okay. The next one is for calculating the RBM. Now, for the RBM, NA is equal to ND divided by NC, then NB divided by NA, then multiplied by ND. So, what is this? 60 number of teeth divided by 20, 25 divided by 18, then multiplied by 1,000. Okay? When we multiply by 1,000, then what do we get? We get NA equals to 4166.67 RPM. And if you track the rotation, you will see that it's counterclockwise or in the positive Z direction. The last part is what is the type of the arrangement gear called compound reverted gear. The next question is about adjusting, since we want to make it in line. We want to adjust the number of teeth to sustain a ratio of 4:1. Now, not all of you made this solution, but I'm gonna teach you the ideal solution. The ideal solution is to observe that ND over NC from the previous calculation was 60 over 20, which is 3. And NB divided by NA is equal to 25 over 18, which is 1.38. Now, using this ratio, if you think about it, using these two, you got 4167 approximately compared to 1,000, which means for each one, you get nearly 4.16. So you take that as a guide and you say, you know what? I'm gonna start by ND over NC. I'm gonna make it 4. Okay, and then I will make NB divided by NA equals to 1. That's what we taught you. So you know that the relation that control the dimension ND plus NC is equal to NA plus NB. Now, if you use this relation and you substitute by multiplying these and then substitute them back, what are you going to get? You're going to get an NA, which is equal to 5/2, which means you need to multiply, you need to have NC as a multiple of 2. So you say, okay, I want NC to be 16. Yeah, instead of, it was 20, I said, okay, let's make it 16. And then if I do that, I will get ND, which is equal to 16 by 4, because the ratio, we set it to be 4. So it's going to be 64. If I use this equation, it will tell me that NA is equal to 40 and NB will have to be 40. Why? Because surprisingly, ya shabab, some of you, so NB has to be 40. Why? Because this is what happens. If this side now is 16 and 64, which is 80. If this is 40, then this must be 40 because you have an equal. This is an equation. So some students solve the problem without even noticing that the left-hand side doesn't equal to the right-hand side. So what the question is asking you later is say, okay, after finding these values, just calculate the gear terrain value, which is E. Well, of course, you take 64 divided by 16, and then you multiply it by 40 over 40, and what do you get? You get a 4. And that's it.